So, hi everyone. Cześć. Welcome to my talk about smuggling, hijacking, and proxying, not in this order, sockets with Rack and Ruby. My name is David. I pronounce my name as Halasz, not as Halasz, as Polish people would think. We had this deal with Hungarians and Polish had this deal with let's confuse the world, how we pronounce the SZ. You can find me on Twitter under this handle. Feel free to tweet about bad stuff. So let's get into this. So I'm from the Hungarian-speaking part of Slovakia, but I live in the Czech Republic in a town called Brno, which is famous for beer. Not my type. MotoGP, if anyone's watching it. And there was a genetical experiment in Brno, a really famous one, but not that one. If you heard about Johann Gregor Mendel, he was experimenting with bees in the city. I work for Red Hat, an open source company, if you would guess. And I'm working on a ManageIQ project, which is an open source hybrid cloud infrastructure management platform. If you have a cloud or an on-premise infrastructure, we're able to manage it. Doesn't matter what kind of providers you use, even multiple at the same time. The important part about this for you at the conference is that it's written in Ruby and Rails, and it has over 1 million lines of code. So, stuff I'm working on, mostly, is in-browser remote consoles, which are basically remote desktop sessions in a browser, surprisingly. So if someone wouldn't know what a remote console is, a remote desktop session is, here is a nice example from Windows, where I don't know the password, but you will get the idea. I see wondering faces, so you never saw this, right? Yeah. So the same in browser. Basically the same stuff in browser. Here you can see a Fluxbox desktop manager running in a browser window. In ManageIQ, we have implemented it in a way that you have a summary screen of a virtual machine. You click on Access in VM console, and you have a pop-up window with the VNC session, something like this. The architecture, you have your VM and your browser. The VM runs on a hypervisor, which runs VMs. And it provides you a VNC endpoint. Even if you're running like VMware or VirtualBox on your local workstation, you can set this VNC endpoint up and run a VNC session, so you can try this out. Unfortunately, the browser doesn't really understand VNC. The closest thing to a streaming is WebSockets. So we need something in the middle. Let's call it proxy. And if you look into this proxy a little closer, even closer, then we see some scary stuff from computer science class, like threads and events and asynchronous I/O and blocking read and all those things. We're gonna touch all of it, don't worry. So if we look into the proxy, inside the proxy, we have two endpoints, or more, but in a simplified version, just two. One for the WebSocket part and one for the VNC part. And you need to transmit data to one direction and to the other direction and somehow translate between the two endpoints. I think it's pretty clear for now, but not Google. So what the hell is this? What is it when I'm talking about endpoints? And if we uncover it, they are basically sockets. Not this kind of sockets, but I was speaking in Australia, they didn't get this joke. So, here is an example of sockets in Ruby. You need to require it if you are not running Rails, because in Rails it's fortunately there because you are using web servers and you know. So here I'm opening an HTTP connection on port 80 to the website of the conference. I'm setting some headers, writing them. I'm getting back some headers, and I'm getting some payload that I'm not using HTTPS, so well played, organizers. You have a secure site. If you look at the operations I'm doing, write, read, close, what things from the other worlds come into your mind? Right. So basically they are files, but for networking. And if you remember your old hard drives which were spinning, or if you are younger, then they were hard drives that were spinning, they were a little slower because you needed some time to the head to get to the data if you were reading. So they came up with the idea of buffering in both directions, in both reading and writing. So when you were writing data, you actually wrote to a buffer. And when you were reading data, you were reading from a buffer which was like prefetched for you. And this thing is actually really useful still for sockets. So when you use sockets and you write to sockets, you actually write to a buffer. And when the operating system, the scheduler in your network card, sees that there is free time on the network card, it's able to send some data through the network. It starts forming packets from this data and sends it out. You don't have to care about it. Problem is, that what happens if the buffer is full? And the answer is easy, you wait. You wait until the buffer gets empty or there is some space in the buffer. This is why it's called blocking write. You block until you don't have the time to do it. And for reading, I was lazy to make slides, so use your imagination. A naive implementation of a proxy using blocking read and write would be something like this. You have two endless loops because you can block here, you can block here. And you need some translation in the middle. And to actually be able to run both of these stuff, you need one of them in a thread. This implementation is probably the worst possible, never use it. Ruby doesn't really handle well threads, and if you have 50 connections, then you need 100 threads, so it doesn't scale really well. So there is a solution for that called non-blocking I/O. You have the same methods with a non-block prefix. Methods aren't waiting if the buffer is full or empty when reading. It just throws you an E would block or E again error depending on the context. And the testing of readiness is extracted out to a separate method or system call. Basically, you can use a single loop to handle all selects. So if you want to read from multiple sockets, you would want to do something like this. You have a thread that runs an event loop that iterates through all the sockets with IO select, which gets you the ready sockets into an array. You iterate through it and read from it and write to your screen. It's really good if you do it in one direction. But when you try to write a proxy for this kind of things, and you don't want to use threads, then you get into problems. So this is my first try of writing a proxy. I cannot really see the screen, so I'm going to walk here. I hope I won't get some echo. So you have a pairing of sockets. You have two sockets A and B, and you have a method paired to that to translate in both directions. And you do an IO select in an endless loop, iterate through all the ready sockets. And if the other part isn't ready, you just skip the iteration. And here you do the same transmission as we did in the threading example, but with non-blocking IO. Problem with this is these two lines can cause you an endless loop, a spin lock. Because if only socket A is ready for reading and socket B isn't ready for writing, feedback loop. So it's not ready for writing, then this IO select will return. The reads array will have one element, the writes will be empty. And this next gets triggered, and we get back here again, where the IO select will again return with the same data, and it will eat up your CPU on 100% and just waste your resources. That's not really good if you want to use this in production. So I started looking into alternatives. First was dropping Ruby, but we're not going to talk about it in a Ruby conference. Using threads with blocking I/O is a bad idea because you need a lot of threads and that doesn't scale well. Or you can use some libraries like Event Machine or Celluloid, which would be cool if we wouldn't use Postgres in async mode in our application. So they are just failing, crashing. There is a cool library, async, which is kind of new and it wasn't available when I started working on this. Also, if I would do it now, I would just use it, but then we will not have this talk. I kind of don't have the font of the like emoji, but it should be a like emoji. Then we can have auto fibers, which are also cool because fibers were already explained, so I'm not going to do that. They are automatically yielding on I/O wait. Normal fibers don't do that. Until you yield your context, they will just run, and you need to explicitly yield. With auto fibers, this will happen automatically if you have a sleep or wait or I/O select call inside the fiber. It's very similar how Crystal implements concurrency. Here's an example, a hypothetical example with auto fibers. You basically have a pool of fibers and you put the two endless loops into that and call them. It's basically magic that converts your blocking I/O into non-blocking I/O with same as you would do in Go or Crystal. Unfortunately, it's not available in Ruby until the version 3. They promise it into the version 3, but we don't have that much time. So the idea I came up with is called bouncing select. The main concept is to make those arrays storing the sockets dynamic. So here is the code a little on steroids, and I marked all the lines I added to those dynamic arrays, and after an I/O select, basically I'm removing the ready sockets from the original arrays, and if a transmission happened, this is a little off, sorry for that. If a transmission happened, we bounce them back. So if socket A is only ready, you get to the I/O select here, you get through it, it gets removed from the to read. On the iteration, it fails because socket B isn't ready for writing, but when we get back to the I/O select, it's no longer there. So we can wait passively, not eating up the CPU. Problem solved. Unfortunately, I/O select isn't ideal if you have thousands of sockets because it's a system call to the kernel and you need to pass all your sockets into the system call every time you call it. So if you have like 500, you have to wait until you copy the socket descriptors into the kernel space before actually waiting for it. So the Linux kernel developers came up with the idea of epoll, where you split up select into two calls. One of them is for registering the socket, and the other one is for actually doing the wait. So this way, you don't have to pass all the time all the sockets. You just register 1 and 2. It's available only on Linux, unfortunately, so sorry Mac users, but you can use KQ, which is kind of similar, or it's possible to fall back to the I/O select in the bouncing version. When I was playing with it, I found a really interesting feature in a flag called epoll one-shot, which basically, after a socket is ready for reading or writing, it gets removed from the array automatically. So basically doing for us this operation here for free. Unfortunately, when I was looking into the Ruby wrappers around epoll, I found like 5 or 6 on the internet. None of them were working well with epoll one-shot, so I had to implement it on my own in C. This is a pseudocode, let's say, from my code base, where I have the register function with a socket and all the in, out, and one-shot flags. And this is the select call where I iterate through the epoll wait results, and I remove the Ruby code, which actually sets the readiness of the sockets that can be consumed in the future. This works well on Linux. Sorry for the Mac users, but here is the repo. If you would like to contribute and write the actual KQ implementation, I would be really happy to merge it, because we also have some Mac developers who are still using the old fallback mechanism. This was like the computer science part of the thing, all the I/O. I would like to talk about WebSockets. All the remote consoles we use are using WebSockets. They are basically HTTP on steroids, upgraded for bidirectional, HTTP 1.1, not HTTP 2. to be precise. They are used for bidirectional transfer after an HTTP upgrade, which I will explain now. So when you have your browser and your web server, your browser sends an HTTP GET request with the upgrade header, which tells the web server that, hey, I'm opening an HTTP connection, but I would like to talk in WebSockets. So the web server sent back an HTTP 101 switching protocols, and after that, the protocol changes, it upgrades to WebSocket. As you know, all the Ruby servers are web servers are implemented in Rack. If you look at Rack, you basically can have anything as a Rack server that responds to a call method and return this three-elemented array with the HTTP status, the headers, and the body. Here you can implement your own server. It doesn't have to be a Lambda, it can be whatever you want. Basically, the whole idea is that you run the server and any incoming request calls this function or method or whatever. So it's basically a function as a server. No. So Rack is really good for request response model, but if you are using WebSocket, you don't really want here to hang on an incoming request. So it's not really good for long-running requests. So the developers of Rack implemented a way to actually get out from this loop or from this function call when you have a persistent connection. It's called socket hijacking. Yeah. I'm sorry for that, GIFs. It's a video about a guy trying to hijack the car. So when we use this hijacking here in a web server, we are able to get the socket that's behind the request that's coming in the env hash, do some magic function to get the other endpoint, in our case the VNC server, and push it to the proxy, which is outside in a separate thread, and be able to serve the next Rack request. We need some dummies here to make Rack happy, so it wouldn't fail that you did an invalid request or something like that, but that's a detail. And basically, this is how our remote consoles work. Here you have the upgrade and the proxy, as you've seen. And I would say thank you, but I promised some smuggling in my talk. So when I was implementing this upgrade and WebSocket part of the remote consoles, I was started thinking about what if we upgrade to something else? Will it work? So when I realized it will, I started to have weird ideas of not upgrading, but downgrading to something else. And my idea was to downgrade to TCP and then send through data in whatever format you want. And the answer why would I do something crazy as this is in this old war when we have your browser applications and desktop applications. And if you think about it, I don't want to offend anyone, desktop application is still faster. And if you think about how slow can be an HTML5 canvas, and you would like to do stuff like key mapping or clipboard, it's not really easy to do, or keyboard shortcuts, it's not really easy to do in browser. So if you want to try to do a VNC remote desktop connection, it's much better experience in desktop. So I came up with this architecture where you have the VM and the hypervisor that gives you the VNC endpoint. On the other side, instead of the browser, you have the VNC client with the VNC connection it wants to create. You have a server proxy that is very similar to the one I showed in the previous slides. And on the client, you would like to have also a client proxy, so they can figure out the language here, which is basically HTTP, but after the upgrade, it becomes VNC. Let's call it PER, because why not? I have those stickers if someone's interested. It actually stands for Protocol Upgrade Raw Request, so it's not like something I just made up. Oh. Yeah, it's part of the show that I'm showing my cat t-shirt, but I got tangled into my... Sorry for that. So PER is basically HTTP upgrade plus VNC, but you can send through SSH or any kind of TCP-based protocol. So it's basically TCP smuggled through HTTP. You open an HTTP connection, you downgrade to TCP and send you whatever you want. In the case of ManageIQ, we are imagining a situation where you have your ManageIQ appliance with the web server and our proxy. You have a virtualized environment, let's say overt, with a VM you want to access. And you click on a new button called Native Console that will send a request to the web server that we would like to open a connection. That sends back a request that go to per://miq, which activates a browser plugin because you cannot open a TCP connection from the browser. The browser plugin opens up, says I'm listening on localhost 1234, which opens a page where they ask you to open localhost 1234. You open in your favorite client localhost 1234, which gets routed to the plugin. Plugin opens a connection. Yeah, it becomes VNC. The plugin opens a connection to the web server, but because the proxy is inside the web server, it will know that it should be sent there with the HTTP upgrade request to PER. HTTP one-on-one arrives. You have your PER connection. In the same time, the proxy opens the VNC connection, and you have your nice tunnel between the VM and the VNC client. There's a problem with all of this, and not talking about that it's complicated. The browser plugin cannot really open a TCP connection. It's still in the browser sandbox, so I kind of lied. You actually need a browser plugin and a client app, but the browser plugin API allows you to call binaries if you have the right permissions. This can be all go away in a few years when the W3C will actually implement the draft for opening TCP connections with user permission inside the browser. So I came up with this architecture with the server. I described the browser plugin and the client, which are communicating with each other, and the missing front-end library because I don't like writing JavaScript. It kind of works. I can show you the server part. It's really similar to Rec. You just pass a block where you need to write your own magic function that gives you a host and a port and run with Puma. Basically, this is how you get to the other endpoint, nothing more. The advantage of this or disadvantages that it behaves like HTTP. So you can do all the routing, all the HTTP headers. You can use HTTPS to secure it. You can have your cookies, your favorite rack middlewares. You can use it in Rails as a route, no problems. The only disadvantage is that it needs a browser plugin and a binary for now. In the future, it might change. It's not fully done and really far from production ready, but it works and I can prove it. I give you some time. Okay, so you probably don't believe me, so I will show you. Talk is cheap, right? I don't know how to exit from full screen from this thing, and it's really hard to see. But yes. Yes, so this is a VNC session running in a remote container. You can see the window. And I will show you how it works. So I have an actual demo where I'm connecting to this. So let's close this window. And so I have a VM defined. Is it visible? Okay, so I have a VM running in a Vagrant box. I'm installing Docker. I'm pulling down 2 containers, one for CentOS, one for an SSH server. This one has a VNC server. I'm setting up for some environment. I'm setting up an etc host file and installing Ruby so I can run perl from the VM. And this is the server I'm running, basically Ruby 2.4 run Puma with perl. Perl looks like this. So depending on the endpoint URL, connect to the VNC server on this port or the SSH server on that port. And we have a nice simple website where we call the plugin with some event dispatching because I still like the front-end library. So I open the URL to VNC or SSH, and when I get the response, I display it on the page. So if I show you the site, here it is, and it's listening on localhost something where I'm actually connected with the VNC. If I hit the stop button, it will close me the connection. So let's try to reopen it. It's really bad with the screen. So I'm connecting to localhost, but it's actually running in a container. And it failed. Typo? Thank you. What did I miss? Oh. Yes. It's here. In the same time, we can open an SSH connection. I just need the port. I have prepared the connection already. So here it is. We're in. And if you don't believe me, it's running on a container. Here I have the Vagrant box. I'm trying to ping from the inside of box the containers. It works. And I'm trying to copy now the IP, or is it 02? Okay, so I leave the Vagrant box. 1702. Did I write it correctly? Okay. So it shouldn't go through because it's not visible. Yep. I'm trying to find my slides. Sorry for that. Yeah, that's all. Thank you. And I believe it was a crazy topic, so we have some questions for sure. You can win the school bag if you ask a question. And I have some stickers. Of course, I have some stickers. Those nice animals. This is the Manage IQ mascot, George. And this is the person. Yeah, thank you. It's yours.
It's not a question, but can I ask some stickers instead of question?
Seriously?
Yeah.
Yes.
Thank you, man.
Any other better questions?
Considering it's a Ruby conference, it will be my last question before I die. But why did you do it in Ruby? I think that there are better texts for proxying requests. And goodbye, guys.
So we have an environment where we cannot run anything else than Ruby for now. So I needed a quick solution, and this is what we used.
since you anyway need a binary on the client side.
For now.
Yes. So for now, wasn't it easier to just make the client install a binary and do it without this browser hassle?
So if you think about like role-based access control and one-time passwords and all those things, you don't want the person who's using your VM somewhere to use it all the time. You want to set some quotas, and you just want to give to the person just some temporary access. In this sense, this one is better because you have a cloud management application that implements you all these access rules, and you can limit the whole VNC session into that scope.
Okay, thank you.
First one.
Hi. Does every Red Hat developer get a Red Hat?
Yes.
Oh.
So when you join the company, you go to a new hire orientation where you can pick one.
Very cool.
Excuse me? We do. I'm not sure about how they get their hats, but I saw on like video conferencing in the background of some of our colleagues' hats, so I'm pretty sure they do as well. Yeah, my colleague here. We have new hire. They have new hire orientation too.
Can you tell us anything about the translation between VNC and the WebSocket? Can you just proxy through the VNC frames, or do you have to do any kind of post-processing, and how efficient it is to do this in Ruby?
It's definitely not the most efficient in Ruby if you are trying to ask about it. You can do it with a method call. So from the one side, from the TCP side, from the VNC side, you just route TCP, and you are basically pushing translation about the remote console in the browser, not in the.
Yes, so you need to somehow convert bitmaps, whatever.
I do, of course.
Okay.
But in the smuggling, you don't have to convert it; just route TCP.
Okay, and one recommendation for the smuggling, you can probably just splice the sockets together at the kernel and never read the data to the user space. There are certain kind of features which allow these, and do not offhand know the exact calls of system calls to splice two sockets together, but it's probably worth to investigate it.
Yep. I tried that one as well, but it was problematic, let's say. Come get some stickers.
Okay, thank you.